Another example of maximum and minimum. So I'm going to take this function. Let's say we have f of x equals x plus 6 over x. And we're interested in the closed interval from, I don't know, -2 to +3. Okay, so that's what we're going to do. We want to find maximums and minimums within that, and we have to find our test points. Obviously, the two endpoints of your interval are always going to be two of your test points. And now what we need to do is find out where this derivative is equal to 0, or where the derivative does not exist. That's another point that you have to use as a test point. Alright, so I'm going to over here write down this equation, x plus 6 over x. We don't do fractions when we have variables in the bottom, so the next step, I'm going to write my little function. Do the rewrite. You're not doing the derivative right now, you're rewriting. You know that if you have x in the denominator, that means you have x to the -1 power. So write that as 6x to the -1 power. Now you're ready to do your derivative. Okay, this x, it's like having x to the first. Bring that 1 out, you get +1, and then when you subtract 1 from your exponent, no more x's. So the derivative of x is just 1. The derivative of 6x to the -1, bring the -1 forward, minus 6x, subtract 1 from your exponent, you get -2. And then always leave it the way you found it. I have a -6 on top. Okay, that looks funky. I want to erase the way I put that negative. I have a negative because it's a negative fraction. The 6 is on top. You have two x's that go in the denominator. All right, that's the derivative. And in order to find test points, I have to set that derivative equal to 0. And you got to solve that crazy old thing. Oops, x squared on the bottom. I got to do a scoot. Oh, I don't want to scoot the whole thing. Okay, I'm gonna do arrow over. You're just gonna have to deal. Okay, arrow over to here. I'm gonna move that 6 over x squared to the other side. So I gotta add 6 over x squared to both sides. So now I have 6 over x squared equals 1. Okay, I'm gonna pick it up. We're walking. We'll put it right there. 6 over x squared equals 1. Okay, cross multiply here. So x squared times 1 is x squared. You really have 1 over 1. 6 times 1 is 6. Okay, so x squared. Man, who made up this stupid problem? Alright, whatevs. So now you do square root. You know you're going to get a positive and negative answer, so the answers, two things, are x equals positive square root of 6 and negative square root of 6. So those are two other test points. The other thing you have to look at is there is a place where the derivative, here's my derivative, there is a place where the derivative does not exist. Okay, you do have x in the denominator. If x is 0, you have a number that doesn't exist. So you also have to use 0 for a test point because that's where your derivative doesn't exist and funky things happen there, so you got to test for that. And then let's see, so our other ones are positive square root of 6 and negative square root of 6. Okay, so those look like they're going to be our test points. Before we bother plugging them all in, let's make sure because sometimes you're going to do problems and not all of those numbers are in your window. So I got to make sure that the square root of 6 is actually in between -2 and 3. So do square root of 6 in your calculator. Square root of 6 is 2.4. Okay, so negative square root of 6 would be -2.4, and that is outside your window. Okay, that's not included in this window here because -2 is the smallest value we could get. -2.4 would be outside that window. So we got to cross out this negative square root of 6 because it's not in our closed interval. Okay, but positive square root of 6 is in the window because we're going all the way to 3, so 2.4 is in there. 0's in that window, and then obviously -2 and 3. Okay, so we cut down our values that we have to test, and now you're going to test them. plug in negative 2. So you get negative 2 plus 6 over negative 2, which is negative 2 plus negative 3. So you get negative 5 for the first one. The second one, you get 3 plus 6 over 3. 6 divided by 3 is 2. So that gives you 5. Plug in 0, we have a problem because you can't plug in 0 there. So that one doesn't exist, so we don't have to worry about that. Positive square root of 6. So we get square root of 6 plus 6 divided by square root of 6. You're going to have to estimate that in your calculator so that we know what that is. Okay. I know I don't like calculators. They're evil. They're bad. But sometimes they're necessary. So you're going to do square root of 6 in your calculator plus, in parentheses, 6 divided by square root of 6, close parentheses twice. You get 4.9 if I round to the nearest tenth. So I'm looking for maximum minimums. Let's do some cleanup here. This is a crazy mess. Okay, I'm gonna separate our work from our answer space. Isn't that lovely? Okay, you're looking for highest and lowest values. The smallest number represented here, so I have negative 5, 5, and 4.9. The negative 5 is our lowest value. So that's our absolute minimum. The positive 5 is our highest value, so that's our absolute maximum. And that's what we got. So on the interval between 2 and 3, the highest point occurs where x is negative 2. The lowest point occurs, nope, I said that wrong. The lowest point occurs where x is negative 2. The highest point occurs where x is 3. And a good thing to do, which I know you won't do it, but you should, is get your graphing calculator out, graph your original function, and look at it and see if in the window from negative 2 to 3, so you can set your calculator window for your x's to go from negative 2 to 3. So look at that and see, is negative 2 definitely the lowest point, and can you see that it's at negative 5? And then positive 3, is that actually at the highest point? And you should notice that it does make a little curve right there, right? Because that's where our derivative was equal to 0. That's one of our points, where the derivative was equal to 0. So you should see a local maximum or minimum at that point. So it's just something to look at. All right, that's example 2.